Hello everyone, this is our third video, and in our first two videos we talked about what quantitative meant, and we also discussed how to use scientific notation. And then I introduced to you what a prefix was. I also talked to you about different measures or different units of measure, for example mass in kilograms, volume in milliliters or liters. And we discussed the difference between a base unit and a derived unit. And so we're going to mainly rely on the metric system. The metric system is the international system of measurement that is used across the world. Even scientists in America, the United States, use the metric system. When you work in a lab, if you decide to do that, if you ever experience that, you will see that all of the units are in metric. We do not use the English units. However, in everyday life, we use English units. These include things like gallons, ounces, pounds. So we need to be able to convert between the English unit and the metric unit, and we're going to get to that. These are the metric prefixes. What's nice about the metric prefixes, what I showed you last time, was that the metric prefixes differ by a factor of 10. And the ones that I highlighted in purple on the screen are the ones that you really are responsible for knowing. These can also be found in the Regents reference table, which I can show you when we are in class. But you need to memorize these, because these are the most important ones that I want you to know. Now, if you notice here, there's the prefix kilo. Kilo is the prefix for 1,000. There's the prefix deci. Deci is 1/10. Centi, 1/100th. Milli, 1,000th. Micro, 1/1,000,000th. Nano, 1/1000,000th. Pico, 1/1,000,000,000th. So these factors, these prefixes, they differ by a factor of 10. So for example, you can see between deci and centi, the difference between them is 10 to the first. The difference between centi and milli is 10 to the second, or 10 to the first also, excuse me. Between micro and nano, or even milli and micro, now they start to increase by a factor of 1,000, 10 to the third. So they're all factors of 10, they just may be multiple factors. Now why do we want to use prefixes? Well, one thing is to try and simplify our lives. For example, instead of writing something as being 6.37 times 10 to the negative 15 meters, a very tiny distance, or grams, very small mass, I could do away with this scientific notation part right here, and I could replace it with the prefix that matches it, which is femto. And so I would have 6.37, and this would be femtometers, or femtograms. Notice when I write a prefix, I put the letter of the prefix followed by the unit. So femtometers would be FM, femtograms would be FG. Now you have to memorize the ones in purple. You should know them. We're going to use them when we do conversions. Now what do these actually mean? Well, these are all compared to the base unit. So let's say, for example, I were to give you something like, something that was 0.0035 grams. Well, if I put this into scientific notation, this would be 3.5 times 10 to the negative 3 grams. If I wanted to write this without using the scientific notation but using a prefix instead, I would look and see or know which prefix was 10 to the negative third. That prefix would be, in this case, milli. Milli's up here as 10 to the negative third. So I could write this as 3.5 milligrams. Now sometimes it won't exactly be there. It'll be close, and then you have to choose which one you want. So I could give you something like this, for example. I could say, well, you have 0.00062 grams. Well, when I put this into scientific notation, I get 1, 2, 3, 4, 5. I would get 6.2 times 10 to the negative 5 grams. When I go to look in my chart, I don't see it there at all. I see a negative 3, I see a negative 6, I don't see a negative 5. Well, there's a couple of ways to do this. I would try and move it to the closest one, and the closest one would be micro, 10 to the negative 6. Well, to make this 10 to the negative 6, I would have 62 times 10 to the negative 6. I move it an extra place. That becomes 62 micrograms. Notice the micro symbol is not correct over here. It should be a script sort of mu, Greek letter mu. Looks like a U with two tails. So to give you an idea, and we're going to practice this in class, but you should pause the video and you should look at these and be like, I need to memorize these prefixes. So go, stop, pause the video, know them. Some of you do this King Henry's drunken uncle drinks chocolate milk or something like that, and that'll get you to milli, and that'll include things like hecto and deca in there, but it doesn't do the smaller ones. Those are a factor of 3, and you got to sit down and memorize them. Maybe you could come up with a new acronym and share it in class if you wanted to. Now, how does this relate to things in our life? And I'll show you a really great video that's like a zoom in, zoom out. And here are some relative sizes of different things, and this happens to be in meters. And so you can see we have at the left side here the essence of small, a proton, a single subatomic particle that makes up parts of elements. 10 to the negative 15 meters. So that would be a femtometer. 10 to the negative 10 would be the length of an atom. And this actually has its own separate unit called an angstrom, and is given the symbol A with that. And that's only for length for that particular measurement. Or you could say it's about 10 nanometers. Or I'm sorry, that's actually 0.1 nanometers. If we go to the micro range, 10 to the negative 6, we have something like a red blood cell. If we didn't have any sort of prefix, just a meter, we would have about the length of a human plus a tennis ball. If we get large, things that are really gigantic, we'd go to something like the distance between the Earth and the Sun. Something extremely large, 10 to the 21, that would be a Milky Way galaxy. And the observable universe, 10 to the positive 27 meters. This next diagram shows you how to visualize this stuff. In order to see things that are really, really small, things that you can't visualize with your eye, we would need something like a light microscope. We can see cells, we can see some organelles. In order to see things that are really, really small, we need something called an electron microscope. And then in order to see something, that's just a normal macroscopic size, we can see that with our eye. Now, what we're going to do is, next time, I'm going to sit down and go over how to convert. How do you take something that's in one unit with one prefix and then convert it to something with another prefix? That's really of great importance. That's what your skill is going to be for this chapter, conversions. To do these conversions, you're going to need to know how to work with scientific notation and what the prefixes are. So when we come back next time for the fourth video in this chapter, we're going to do some factor label method, some dimensional analysis. See you next time.